Hello there, and welcome to Sleep Science Drift. I'm so glad you're here. Maybe it's been a long day. Or maybe you're the kind of person who likes to fall asleep thinking about distant planets and drifting moons instead of counting sheep. Either way, tonight's journey is for you. You don't need to do anything now but rest. Let your breath slow, your thoughts soften, and your body grow light as if gravity has loosened its grip and you've begun to float quietly through space. Because tonight, we're going to drift gently through the solar system. Not in a straight line, but in soft spirals from sunlit planets and dusty rings to shadowed craters and frozen oceans hidden beneath the ice. A story told not in numbers, but in magnetic storms, tilted axes, and moons that glow in the dark. From sideways worlds and diamond rains to ancient sunlight still crossing the void, every orbit holds something strange and beautiful. We'll go slowly, gently, just one sleepy fact at a time. And just before we begin, if these quiet explorations help you unwind or give you a peaceful way to end your day, consider gently tapping the like button and subscribing to the channel. It helps others find their way here, too, one sleepy soul at a time. Now, let's begin. Neptune's winds break the speed of sound. Despite being the farthest known planet from the Sun, Neptune hosts the fastest winds in the solar system. These winds whip through its upper atmosphere at speeds exceeding 2,000 kilometers per hour, faster than the speed of sound on Earth. That's roughly 5 times the speed of a commercial jet. The winds likely derive their energy from the planet's internal heat, which continues to radiate outward despite the freezing conditions at its surface. Neptune's atmosphere is composed mostly of hydrogen, helium, and methane, and the winds carve massive storm systems into the planet's pale blue clouds. It's a frozen world in constant supersonic motion. Mars holds a canyon the size of a continent. Stretching more than 4,000 kilometers across the Martian equator, Valles Marineris is the largest canyon system in the solar system. It would span the entire width of the continental United States. In places, it plunges over 7 kilometers deep, more than 5 times deeper than the Grand Canyon. Scientists believe it formed through a combination of tectonic stretching, volcanic activity, and erosion. Unlike Earth's canyons, which are typically carved by rivers, this vast chasm opened as the planet's crust cracked and pulled apart. It is a scar on the Martian surface, hinting at a violent geological past, now frozen in time. Venus has no magnetic field. Despite being similar in size, mass, and composition to Earth, Venus lacks one crucial planetary feature: a global magnetic field. Earth's magnetic shield is generated by the motion of molten iron in its outer core, protecting the planet from solar radiation. Venus, however, seems to have a sluggish or possibly solid core, which prevents the kind of dynamo effect needed to create a field. Without this protection, Venus's atmosphere is constantly bombarded by solar wind, which has stripped away lighter elements over time. The absence of a magnetic field helps explain why Venus, once possibly Earth-like, became a furnace world. Diamonds may rain on Uranus and Neptune. Deep within the atmospheres of Uranus and Neptune, conditions are extreme enough to create something extraordinary: falling diamonds. These icy giants have thick layers of methane gas. Under immense pressure and heat, scientists believe the methane breaks apart, releasing carbon atoms. These carbon atoms then compress into crystalline structures, forming tiny diamonds that rain down toward the core. Laboratory experiments have simulated this process, showing how hydrocarbons condense into diamond under the right conditions. If this theory is correct, storms of glittering crystals drift through the deep blue darkness of distant gas giants. Earth is the only planet with plate tectonics. One of Earth's most distinctive and life-enabling features is its dynamic network of shifting crustal plates floating atop the mantle. These moving plates create earthquakes, build mountains, and recycle carbon dioxide, regulating the climate over geologic time. So far, no other planet shows clear evidence of this process. Mars and Venus have surface fractures and volcanic features, but they appear geologically stagnant by comparison. Earth's plate tectonics help make it habitable, driving long-term cycles that stabilize temperature, support oceans, and enable the movement of continents over eons. Some asteroids have their own moons. While we often picture asteroids as solitary wanderers, some actually have smaller bodies orbiting around them. These tiny satellites are usually capture fragments or co-form companions. The first discovered asteroid moon was Dactyl, which orbits the asteroid Ida, revealed by the Galileo spacecraft in 1993. Since then, dozens more asteroid moon systems have been found, including binary arrangements where two asteroids orbit each other. These miniature systems show that even in the vastness of space, gravity can link the smallest of objects into quiet, drifting partnerships. Mercury has a ghostly exosphere instead of a true atmosphere. Unlike Earth, Mercury doesn't have a thick atmosphere to retain heat or scatter light. Instead, it has a thin, tenuous shell of particles known as an exosphere, a near vacuum where atoms bounce around without colliding. This exosphere is made of atoms blasted from the surface by solar wind and micrometeoroid impacts, including sodium, potassium, and oxygen. Because Mercury lacks the gravity to hold a real atmosphere, these particles constantly escape into space and are replenished from the surface. The result is a ghostly shimmering envelope of scattered atoms, invisible to the eye, but detectable with the right instruments. The Sun loses millions of tons of mass every second. Every second, the Sun converts over 4 million tons of its own mass into energy through nuclear fusion. In its core, hydrogen atoms fuse into helium, releasing light and heat that powers our solar system. This energy radiates outward in all directions, warming planets, driving winds, and fueling life on Earth. Though the loss is minuscule compared to the Sun's total mass, over billions of years it adds up. Eventually, the Sun will exhaust its hydrogen fuel and begin to change. But for now, it continues to burn steadily, sacrificing a tiny part of itself with every passing second. Saturn's rings are slowly disappearing. The beautiful rings that encircle Saturn are not permanent. They are gradually falling into the planet, drawn in by gravity and pulled down by Saturn's magnetic field. This process, known as ring rain, involves streams of ice particles and charged material drifting inward over time. Observations from the Cassini spacecraft suggest that the rings may be less than 100 million years old, young by planetary standards, and could vanish entirely in another few hundred million years. Though they seem timeless, Saturn's rings are a temporary feature, a shimmering spectacle that will one day fade into memory. Mars experiences planet-wide dust storms. Mars is known for its rusty desert landscape and for colossal dust storms that sometimes engulf the entire planet. These storms can last for weeks or even months, blocking out sunlight and reshaping the surface. The dust is incredibly fine and stays suspended in the atmosphere, creating a hazy reddish glow. Some storms begin as small gusts, but grow rapidly due to feedback loops between heat, wind, and topography. In 2018, such a storm led to the end of the Opportunity rover's mission as its solar panels choked with dust. Even without rain or oceans, Mars remains an active and restless world. Europa may have a salty ocean beneath its ice. Beneath the frozen shell of Jupiter's moon Europa, there is strong evidence for a vast subsurface ocean of liquid water. Tidal forces from Jupiter's gravity flex Europa's interior, generating heat that keeps the ocean from freezing solid. The surface is streaked with dark lines and ridges, signs of shifting ice, and spacecraft have detected magnetic signatures and chemical traces supporting the ocean hypothesis. What makes Europa especially fascinating is the possibility that this hidden sea could harbor life. It's a dark, alien ocean, warmed from below, sealed beneath ice, yet potentially rich with ingredients for biology. Mars has a volcano taller than Everest. Olympus Mons, the tallest volcano in the solar system, towers nearly 22 kilometers above the Martian plains, almost 3 times the height of Mount Everest. It's so wide that it would cover the entire state of New Mexico. Formed by repeated eruptions over millions of years, Olympus Mons grew so large partly because Mars lacks plate tectonics. On Earth, volcanic hotspots shift over time, creating chains of islands like Hawaii. But on Mars, the crust remains still, allowing magma to erupt in the same spot again and again. The result is a single massive shield volcano that looms silently in the Martian night. Saturn's rings are paper thin. Saturn's majestic rings stretch more than 280,000 kilometers across, yet they're astonishingly thin. In most places, the rings are less than 100 meters thick, thinner than many city buildings. Made mostly of water ice, ring particles range in size from grains of dust to house-sized boulders. When sunlight passes through the ring zone, they nearly disappear from view like a sheet of glass turned sideways. Their flatness is maintained by the planet's gravity, the self-organization of icy fragments, and the influence of small shepherd moons. From a distance, they appear solid, but up close, they're delicate and ethereal. Earth is the densest planet. Of all the planets in the solar system, Earth packs the most mass into each cubic centimeter, thanks to its metal-rich core and silicate mantle. Earth's density is about 5.5 grams per cubic centimeter, higher than that of Jupiter, despite the gas giant's far greater size. This high density plays a key role in generating Earth's magnetic field via the motion of molten iron in its outer core. Our planet's internal structure is compact, heavy, and layered, shaping not just its gravity, but its geology and protection from space. The sun vibrates like a musical instrument. Though we can't hear it with our ears, the sun constantly rings with pressure waves rippling through its blazing layers. These oscillations, caused by rising and falling currents of plasma, generate ultra-low frequency sounds far below human hearing. Scientists study these vibrations through helioseismology. By tracking how waves travel and bounce within the sun's body, researchers map its internal structure, much like geologists use seismic waves to explore Earth's interior. These solar songs reveal hidden flows, magnetic activity, and the dynamics of fusion deep within the core. In a way, the sun is always humming quietly, revealing its secrets through vibration and rhythm. Venus rotates backward. Unlike most planets in the solar system, Venus spins in the opposite direction, a phenomenon known as retrograde rotation. On Venus, the sun rises in the west and sets in the east. Even stranger, its rotation is incredibly slow. A single day on Venus lasts longer than its year, taking 243 Earth days to complete one rotation. Scientists aren't certain why this happened, but one possibility is a massive collision early in its history that altered its spin. Another theory suggests tidal interactions with the sun slowly flipped its axis over time. Whatever the cause, Venus stands alone as a slow-turning world with a reversed rhythm. Jupiter has more than 90 moons. The gas giant Jupiter is not just the largest planet, it's also the king of moons. Astronomers have identified over 90 natural satellites orbiting it, and new ones are still being discovered. Its four largest moons, Io, Europa, Ganymede, and Callisto, are known as the Galilean moons, named after Galileo Galilei, who first observed them in 1610. Beyond these giants lies a swarm of smaller, irregular moons, many captured from passing objects. Some orbit backward, and some are just a few kilometers across. Together, they form a miniature solar system in orbit around Jupiter, bound by the planet's immense gravity and history. Mercury hides ice in its shadows. Scorching during the day and freezing at night, Mercury is not where you'd expect to find ice. Yet it's there. At its poles, deep inside craters that never receive sunlight, temperatures remain cold enough for water ice to exist. These permanently shadowed regions act like natural freezers, preserving ice for millions of years. Radar reflections from spacecraft like Messenger have confirmed the presence of these bright, icy patches. Scientists believe the water may have arrived from comet impacts or ancient volcanic outgassing. In the heart of one of the hottest planets, ice survives, locked in darkness and shielded by crater walls from the relentless solar blaze. Pluto's heart may hide an ocean. The bright heart-shaped feature on Pluto, known as Sputnik Planitia, isn't just a scenic landmark. It may be the surface expression of a vast underground ocean. Though Pluto is far from the Sun and cold enough to freeze nitrogen, evidence from the New Horizons spacecraft suggests a layer of liquid water might lie beneath its icy crust. The weight of the basin and its apparent geological activity hint at a slushy, convecting subsurface. If this ocean exists, it could be kept liquid by heat from radioactive decay and insulating ice layers above. Even in the frozen reaches beyond Neptune, a hidden sea may quietly persist. The asteroid belt is mostly empty space. Despite popular imagination, flying through the asteroid belt wouldn't be like dodging rocks in a sci-fi movie. In reality, the belt is vast and sparsely populated. Located between Mars and Jupiter, it contains millions of rocky bodies, but they are separated by enormous distances. A spacecraft passing through would almost never encounter an obstacle. The entire mass of the asteroid belt is less than 5% that of the Moon. Its largest members, like Ceres and Vesta, account for most of that, while the rest are scattered ancient building blocks that never formed into a planet. Uranus rolls around the Sun. Most planets spin like tops, tilted slightly on their axis, but Uranus is tipped so far over that it essentially rolls along its orbital path with an axial tilt of 98 degrees. This means its poles point almost directly at the Sun during parts of its orbit, giving it extreme and bizarre seasons. Each pole experiences 42 years of daylight, followed by 42 years of darkness. The cause of this tilt is still debated, but it may have been knocked sideways by a massive collision long ago. This tilted orientation gives Uranus one of the strangest climates in the solar system. Jupiter's radiation belts are deadly. Jupiter is surrounded by the strongest magnetic field of any planet. Within it are radiation belts so intense they would destroy unprotected spacecraft in hours. These belts are filled with charged particles trapped by the planet's magnetic field, forming zones of high-energy radiation similar to Earth's Van Allen belts, but vastly more powerful. Jupiter's largest moons are exposed to this radiation too, which can affect their surfaces and potential habitability. To survive in orbit around Jupiter, spacecraft must take special shielding measures or stay clear of radiation paths. It's a beautiful world, but one wrapped in invisible danger. The Sun contains nearly all the mass in the solar system. At the heart of our solar system, the Sun dominates not just with light and gravity, but with sheer mass. It holds over 99.8% of all the mass in the solar system. That means everything else, all the planets, moons, asteroids, comets, and dust, makes up less than 1/4%. Its gravitational pull binds everything in orbit, from tiny grains in the asteroid belt to distant comets in the Oort cloud. This immense mass fuels the fusion reactions at its core, converting hydrogen into helium and flooding space with the energy of day. There are more dwarf planets than classical planets. Beyond Neptune lies a scattered population of icy, distant objects, many large enough to qualify as dwarf planets. Pluto is the most famous, but it's just one among many. Others like Eris, Haumea, and Makemake share this status, and more candidates are constantly being discovered in the Kuiper belt and beyond. In fact, the number of dwarf planets may vastly exceed the 8 classical planets. These small round worlds are untouched relics of the early solar system, holding clues to the formation of everything we know. A day on Venus lasts longer than its year. Venus has one of the slowest rotations of any planet. It takes 243 Earth days to spin once on its axis, while it only takes 225 days to complete one orbit around the Sun. That means a single day on Venus, from one sunrise to the next, is actually longer than a full year. This sluggish spin contributes to extreme surface conditions with temperatures hot enough to melt lead. Combined with its thick, acidic atmosphere and crushing pressure, Venus is a world of slow, simmering heat and eerie, sunless days. Titan has lakes made of methane. Saturn's largest moon, Titan, is the only other place in the solar system known to have stable liquids on its surface, but they're not made of water. Instead, Titan's lakes and rivers consist of liquid methane and ethane flowing across a landscape sculpted by cold chemistry. Its thick atmosphere, rich in nitrogen, forms weather systems that include methane rain and seasonal storms. Some of Titan's lakes stretch hundreds of kilometers. Beneath the icy surface, scientists believe a subsurface ocean of water may also exist. Titan is a world with familiar shapes, clouds, rivers, and coasts, built from alien substances. The moons of Mars may be captured asteroids. Mars has 2 tiny, misshapen moons, Phobos and Deimos. They look more like asteroids than traditional moons, irregular, rocky, and pockmarked with craters. Many scientists believe they were once part of the asteroid belt and were captured by Mars's gravity long ago. Their strange orbits and low densities support this idea, though some alternative theories suggest they formed from debris after a massive impact. Phobos is slowly spiraling toward Mars and will eventually break apart or crash into the planet, while Deimos is drifting away. These little moons are quiet passengers in orbit, remnants of a chaotic past. Jupiter glows with its own heat. Unlike most planets, Jupiter gives off more energy than it receives from the Sun. This internal glow comes from leftover heat from its formation, gravitational energy released when the planet's immense mass collapsed together. Over time, it continues to contract slightly, generating heat in the process. This warmth drives Jupiter's turbulent weather systems, including giant storms and swirling bands. In the infrared spectrum, Jupiter shines brightly like a smoldering coal beneath cloud layers. It's not a star, but it almost became one. Had it been just a bit more massive, it could have ignited into a failed sun. Neptune was discovered through math. Unlike other planets, Neptune was not discovered by simply looking through a telescope. Instead, astronomers noticed irregularities in Uranus's orbit, tiny deviations that couldn't be explained by known gravity. Two mathematicians working independently in the 1840s used these strange motions to predict the location of a hidden planet. When astronomers pointed their telescopes toward the calculated position, Neptune was there. It was a triumph of celestial mechanics, confirming that unseen forces could be mapped through mathematics alone. Neptune was the first planet found on paper before it was seen through glass, a world brought to light by numbers. Saturn's North Pole has a hexagon. At Saturn's North Pole, a massive cloud pattern spins in the shape of a nearly perfect hexagon. This six-sided jet stream spans over 30,000 kilometers across, wider than Earth, and has persisted for decades, possibly centuries. Scientists believe the hexagon forms from the way Saturn's atmosphere rotates and interacts with stable waves of air trapped around the pole. In lab experiments, similar shapes appear when rotating fluids at different speeds. The fact that such a geometric shape can emerge naturally in a planetary atmosphere remains one of the most surreal and elegant phenomena in the solar system. The Sun's atmosphere is hotter than its surface. It might seem intuitive that the hottest part of the Sun would be its surface, but it's not. The visible surface, or photosphere, has a temperature of about 5,500 degrees Celsius. Yet, the outer atmosphere, known as the corona, can reach over 1,000,000 degrees. This unexpected increase in temperature has puzzled scientists for decades. One theory suggests magnetic waves from deep within the Sun transfer energy upward and heat the corona from below, while another points to tiny solar explosions called nanoflares. Either way, the Sun's outer layers glow with mysterious searing heat far beyond their source. The Kuiper belt is full of icy worlds. Beyond Neptune lies a wide ring of icy objects known as the Kuiper belt. It stretches billions of kilometers from the Sun and is home to countless frozen bodies, including Pluto, Eris, Haumea, and Makemake. These are ancient remnants from the solar system's formation. Some are spherical and classified as dwarf planets, while others are irregular, tumbling through space. The Kuiper belt is similar in structure to the asteroid belt, but far colder and richer in primordial ice. It's a fossil zone, a frozen archive of the materials that built the outer worlds. The Oort cloud may stretch a light year from the Sun. Far beyond the Kuiper belt, even beyond Pluto's furthest reach, lies a hypothetical shell of icy bodies known as the Oort cloud. Though never directly observed, this vast sphere of frozen debris is thought to encircle the solar system and extend nearly a light year away. It's the likely source of long-period comets, which appear from the depths of space with unpredictable orbits. These distant objects are weakly bound to the Sun, and a passing star or galactic tide can send one hurtling inward. If the Oort cloud exists, it marks the true edge of the Sun's gravitational influence, a distant halo of icy wanderers. Io is the most volcanic world in the solar system. Jupiter's moon Io is a seething, restless world covered in active volcanoes. Its surface is constantly reshaped by eruptions of molten sulfur and rock, painting the landscape in vivid yellows, reds, and blacks. Some volcanic plumes, rise hundreds of kilometers into space. This extreme activity is driven by tidal heating. Io is squeezed and stretched by Jupiter's gravity alongside gravitational tugs from neighboring moons. The friction from this constant flexing heats its interior, powering a furious geology. Unlike Earth's cooling crust, Io's surface is young, volatile, and ever-changing, a lava-lit moon with a molten heart. Triton orbits backward around Neptune. Triton, Neptune's largest moon, is unique among large moons because it orbits its planet in the opposite direction of Neptune's rotation, a retrograde orbit. This backward path suggests Triton did not form alongside Neptune, but was likely captured from the Kuiper belt. That capture may have caused dramatic upheaval, disrupting Neptune's original satellite system. Triton is also geologically active, featuring cryovolcanoes that spew icy material into space and a thin atmosphere, shifting with the seasons. Cold, distant, and moving in reverse, Triton defies expectations at every turn. Earth's moon is unusually large. Compared to the size of its host planet, Earth's moon is enormous. No other rocky planet in the solar system has such a relatively large satellite. The moon is about 1/4 the diameter of Earth, a ratio more typical of dwarf planet systems than rocky planets. Most scientists believe the moon formed after a Mars-sized body collided with a young Earth, ejecting debris into orbit that eventually coalesced. This close partnership has profoundly influenced Earth's tides, climate, and stability over billions of years. Our moon is a cosmic legacy of planetary collision and renewal. Planetary orbits are not perfect circles. Although we often imagine planets moving in circular paths, their orbits are actually ellipses, stretched circles with the sun offset from the center. This elliptical shape means each planet has a closest point to the sun called perihelion and a farthest point called aphelion. For most planets, the difference is subtle, but for Mercury and Pluto, it's more dramatic. These variations influence seasons, solar radiation, and orbital speed. The elliptical nature of planetary motion was first described by Johannes Kepler in the 1600s, reshaping our understanding of the solar system's elegant mechanics. Some comets come from the edge of interstellar space. Long-period comets, the kind appearing once every few thousand years, are believed to come from the Oort cloud, a distant shell of icy debris nearly a light year away. These comets travel on elongated, loosely bound orbits and are often dislodged by passing stars or galactic tides. When they fall inward toward the sun, they light up with spectacular tails visible even from Earth. Having spent billions of years drifting in darkness, their bright returns are fleeting glimpses of the solar system's most ancient, untouched matter. The sun will become a white dwarf. The sun, like all stars, has a finite lifetime. In about 5 billion years, it will exhaust the hydrogen fuel in its core and expand into a red giant, engulfing the inner planets. After shedding its outer layers in a glowing shell of gas called a planetary nebula, the remaining core will become a white dwarf, a dense, Earth-sized remnant made mostly of carbon and oxygen. This white dwarf will no longer produce energy, but will slowly cool over trillions of years. It will be the final form of our sun, a glowing ember in the darkness marking the end of its stellar journey. Mars has seasons like Earth. Though colder and thinner in atmosphere, Mars experiences seasons much like our own planet because its axial tilt is roughly 25 degrees, closely matching Earth's 23.5. As it orbits the Sun, this tilt causes sunlight to strike different hemispheres more directly at different times of year. The result is a cycle of spring, summer, autumn, and winter with varying temperatures. Martian seasons also influence polar ice caps, dust storms, and air pressure, though they unfold more slowly since Mars takes nearly twice as long to complete a year. Ganymede is the largest moon in the solar system. Jupiter's moon Ganymede is larger even than the planet Mercury, boasting a diameter of over 5,000 kilometers, a rocky core, a possible subsurface ocean, and a crust covered in ridged ice and ancient scars. Uniquely, it is the only moon known to generate its own magnetic field, creating shimmering auroras in its thin atmosphere. Scientists believe Ganymede may feature multiple ocean layers sandwiched between ice sheets. Despite its size and complexity, it remains quiet and dark, orbiting deep within Jupiter's magnetic grasp. Pluto sometimes orbits closer to the Sun than Neptune. Although Pluto is usually the most distant dwarf planet, its orbit is highly elliptical, meaning it periodically travels closer to the Sun than Neptune. This last occurred between 1979 and 1999. Even so, the two worlds never collide or come dangerously close because their orbits are locked in resonance. For every 3 orbits Neptune makes, Pluto completes exactly 2. This gravitational choreography keeps them in a stable dance where their paths never cross, a delicate balance governed by celestial rhythm and time. The Sun reverses its magnetic field every 11 years. Roughly every 11 Earth years, the Sun's magnetic north and south poles switch places. This process, known as the solar magnetic cycle, is tied to internal dynamics and governs solar activity, including sunspots, flares, and coronal mass ejections. At the peak, called solar maximum, the Sun is active with intense radiation and magnetic storms. As the cycle wanes, activity drops to solar minimum. These cycles influence Earth's upper atmosphere and auroras, proving the Sun's magnetism pulses like a breathing heartbeat. Planetary alignments don't cause natural disasters. It's a common myth that planetary alignments trigger earthquakes or floods on Earth, but there is no scientific evidence for this. The gravitational pull of distant planets is minuscule compared to our nearby Moon or Sun. Even during rare alignments, their combined influence is negligible. The Moon's close proximity exerts far more tidal and seismic stress. Planetary alignments are beautiful and mathematically interesting, but gravitationally harmless. A silent dance of distant worlds, not an omen. Leaving the solar system takes decades. Escaping the Sun's gravity is no small task. Spacecraft like Voyager 1 and 2, launched in the 1970s, have only recently entered interstellar space. These missions took over 40 years to reach that boundary, traveling outward at speeds exceeding 60,000 kilometers per hour. Having crossed the planetary orbits and the Kuiper belt into the dark, the probes carry functioning instruments and a golden record filled with sounds of Earth, our quiet ambassadors to the galaxy. Earth's magnetic field shields us from space radiation. Surrounding our planet is an invisible magnetic field generated by molten iron moving in the outer core. This field deflects charged particles from the sun, protecting the atmosphere and surface from harmful radiation. Without it, the solar wind would gradually erode our atmosphere, as it likely did on Mars. The field also funnels particles toward the poles to create shimmering auroras. Earth's magnetosphere is a dynamic shield essential for preserving life and climate over geological time. The Moon is slowly moving away from Earth. Each year, the Moon drifts about 3.8 centimeters farther away due to tidal interactions. In the distant past, the Moon was much closer and appeared significantly larger in the sky. As it recedes, our days gradually lengthen and solar eclipses become less frequent. Billions of years from now, the Moon's orbit will be so wide that total solar eclipses will no longer be possible. The sky is changing, even if we don't feel it day by day. The Kuiper belt holds icy worlds with mirrored surfaces. Far beyond Neptune, the Kuiper belt contains small, icy bodies with startlingly bright surfaces. One example is Haumea, a fast-spinning, football-shaped object coated in crystalline water ice, while Eris reflects nearly all sunlight hitting it, brighter than fresh snow. Resurfaced by cryovolcanism or impacts, these distant worlds gleam like cold mirrors in the frozen silence at the edge of the solar system. Enceladus sprays water into space. Saturn's tiny moon Enceladus hides a spectacular secret. Towering geysers of water vapor and ice crystals erupting from its south pole through cracks known as tiger stripes. These plumes are powered by tidal heating, where friction from Saturn's gravity keeps a subsurface ocean liquid. The plume material contains organic compounds, salts, and hydrothermal activity signs, raising the tantalizing possibility of life. Escaping water also helps replenish Saturn's E-ring, linking moon and planet. Some asteroids are just piles of rubble. Not all asteroids are solid rock. Many are loose collections of stones, gravel, and dust held together only by weak gravity. These fragile bodies form after collisions shatter larger asteroids, with debris slowly reaccumulating over time. Rubble pile asteroids can feature large internal voids and change shape under pressure. Missions like Hayabusa 2 and OSIRIS-RX have confirmed their delicate, porous nature, ancient drifting ruins barely holding themselves together. Mercury's core is disproportionately large. Mercury is a small planet, but boasts an unusually massive iron core, making up about 80% of its radius. Some scientists believe Mercury once had a thick, rocky mantle stripped away by a giant impact, while others think it formed close to the Sun, where solar forces favored heavy elements. The result is a planet with a thin crust, a huge core, and a weak magnetic field, a metal-heavy survivor from the system's chaotic youth. Venus has no moons at all. Among rocky planets, only Mercury and Venus lack natural satellites. While Mercury's solar proximity explains its lack of moons, Venus's situation is more puzzling since it's Earth-sized. Theories suggest it may have had a moon that fell back or was lost in a collision, or that its slow retrograde rotation prevents stable orbits. Whatever the cause, Venus orbits alone, a bright, cloud-wrapped world with no lunar companion. The giant planets of the outer solar system are surrounded by sprawling systems of satellites. While Earth has one moon and Mars two, Jupiter and Saturn each boast dozens of confirmed moons ranging from tiny captured asteroids to massive worlds like Ganymede and Titan, with Uranus and Neptune also hosting complex icy families. These gas giants act like miniature solar systems, gathering debris over time. The farther from the sun you go, the more companions gravity gathers in the cold. Hubble has photographed planets from Earth orbit. Though orbiting just above Earth, the Hubble Space Telescope captures detailed images of outer planets, tracking cloud bands on Jupiter, storms on Neptune, and seasonal changes on Mars. These images provide long-term observations, complementing spacecraft flybys. Hubble's clarity lets scientists monitor storm development, impact events, and atmospheres in ultraviolet and visible light, watching the shifting faces of neighboring worlds from a quiet low Earth orbit. Jupiter's Great Red Spot is centuries old. This massive storm in Jupiter's southern hemisphere is wide enough to swallow multiple Earths and has raged for at least 350 years. Though gradually shrinking over time, it remains powerful, driven by complex chemical reactions and wind speeds exceeding 400 kilometers per hour. While Earth storms last days or weeks, this Jovian tempest spans centuries trapped within turbulent belts. Neptune radiates more heat than it receives from the sun. Although distant, Neptune is not a frozen, inert world. It radiates about 2.6 times more energy than it takes in. This internal heat drives strong winds and storm systems, including the fastest recorded winds in the solar system. Though the exact source remains uncertain, whether residual formation energy, gravitational contraction, or core decay, Neptune is a world of surprising energy, maintaining a warm interior beneath a cold exterior. Earth is the only planet with water in all three states. Water exists naturally on our surface as ice caps and glaciers, liquid oceans and lakes, and atmospheric clouds and vapor. This balance, crucial for life, is regulated by Earth's distance from the sun, atmospheric pressure, and stable climate. While other worlds may feature ice crusts or hidden subsurface oceans, none match Earth's dynamic, planet-wide presence where water flows, freezes, and evaporates in an endless cycle. The heliopause marks the edge of the sun's influence. As the solar wind flows outward, it eventually collides with the interstellar medium, the gas and dust between stars. This boundary defines the outer edge of the heliosphere. Beyond this point, pressure from other stars overcomes the solar wind. Voyager 1 crossed this boundary in 2012, followed by Voyager 2 in 2018, entering true interstellar space. Though solar gravity extends further, the heliopause marks the final breath of active solar influence before deep space begins. The solar system is drifting through a local cloud. Our entire system moves through the local interstellar cloud, a thin concentration of gas and dust about 30 light-years across within the local bubble. Traveling at about 70,000 kilometers per hour, our heliosphere acts as a shield against interstellar material. Scientists study this cloud to understand how interstellar conditions affect cosmic rays and Earth's climate. We are not sitting still, but sailing silently through a galactic fog. Some moons are geologically active. Planetary status isn't required for geological activity. Io has active volcanoes from tidal heating. Enceladus vents water vapor plumes. Europa and Ganymede hide subsurface oceans, and Triton shows cryovolcanism. These are not static ice balls, but restless worlds with geology, chemistry, and potential habitability hidden beneath frozen exteriors. Pluto's atmosphere comes and goes. Pluto features a thin atmosphere of nitrogen, methane, and carbon monoxide. As it approaches the Sun in its elliptical orbit, surface ices sublimate into a hazy envelope expanding into space. But as it moves further out, the atmosphere cools and freezes back onto the surface like frost. During the 2015 New Horizons flyby, this atmosphere appeared as a layered blue haze, a fleeting breath of warmth around a world spending most of its time in deep cosmic winter. Temperatures at the Sun's core exceed 15 million degrees Celsius. Under immense pressure, hydrogen atoms fuse into helium, releasing enormous energy that powers the Sun. This core energy takes hundreds of thousands of years to bounce through dense plasma layers to the surface. But once escaped, light crosses space to Earth in just over 8 minutes. The Sun's radiant calm hides an unimaginably hot, violent heart. Uranus has a faint tilted ring system. Uranus features 13 dark, narrow rings made of tiny rock and ice particles orbiting in alignment with its extreme axial tilt. Because the planet lies almost on its side, the rings appear vertical when viewed from above the poles. Shaped partly by small shepherd moons, these subtle bands weren't discovered until 1977 when they blocked background starlight, shading a sideways planet. Mercury's orbit helped prove Einstein's theory of gravity. For centuries, astronomers noticed Mercury's perihelion shifted more than Newtonian physics allowed. In 1915, Einstein's general relativity provided the solution. Massive objects like the Sun warp space-time, subtly altering planetary paths. Mercury's measured orbital shift matched Einstein's predictions exactly, offering a foundational confirmation of his theory and a triumph of mathematical physics. The Moon shapes Earth's tides. Ocean tides are driven largely by the gravitational pull of the Moon, creating bulges on facing and opposite sides of the Earth that produce high and low tides as the planet rotates. The Sun also influences spring and neap tides. These tidal forces subtly shift Earth's crust and influence planetary rotation, keeping the global oceans in steady motion. There may be undiscovered planets beyond Neptune. Distant Kuiper belt objects follow clustered, elongated orbits unexplained by known planets. A leading theory suggests a massive Planet 9, several times Earth's mass, orbits far beyond Pluto. While direct evidence remains unconfirmed and telescopes continue searching, finding it would reshape our understanding of the solar system's outer architecture. Callisto may have an ocean beneath its icy surface. Jupiter's moon Callisto appears heavily cratered and ancient, but deep beneath its crust, scientists suspect a conductive subsurface ocean of salty water kept liquid by internal heat. If confirmed, Callisto would join Europa and Ganymede as an ocean world, potentially sealing ingredients for life beneath its ice. Venus is hotter than Mercury despite being farther from the Sun. Although Mercury is closer, Venus holds the record for surface heat due to a runaway greenhouse effect driven by a thick carbon dioxide atmosphere. Surface temperatures exceed 460 degrees Celsius, hot enough to melt lead. While dense clouds reflect sunlight, they trap outgoing heat entirely, whereas Mercury's thin exosphere cools rapidly on its dark side. The rings of Saturn are made mostly of ice. Shimmering like solid bands, Saturn's rings consist of countless water ice particles ranging from dust grains to house-sized chunks orbiting in a flat, thin disk. Maintained by gravity and nearby moons, the ice provides brilliant reflectivity, while narrow gaps and wave patterns are sculpted by gravitational resonances in this dynamic structure. Ceres is both an asteroid and a dwarf planet. Located in the asteroid belt between Mars and Jupiter, Ceres is the largest object in that region and spherical enough to qualify as a dwarf planet. The Dawn spacecraft revealed mysterious bright spots of salt deposits left by evaporating water, offering a hybrid glimpse into early planetary ingredients. Mars appears red because of rust. The Martian surface is coated in fine iron oxide dust that has oxidized over billions of years, creating the planet's signature hue. This pervasive dust colors the skies during storms and coats the globe alongside dark basaltic plains and polar ice caps, presenting a striking signal of oxidation on a cold desert world. Sunspots are cooler regions on the sun's surface. Though the sun blazes intensely, sunspots appear darker because they are cooler than their surroundings, caused by intense magnetic activity suppressing heat flow. Following an 11-year cycle, these magnetic scars are extremely hot, yet visually darker by contrast, revealing the sun's shifting internal dynamics. Uranus was discovered by telescope. Identified in 1781 by William Herschel, Uranus was the first planet discovered in modern times, expanding known borders and marking a shift to instrument-based astronomy. Since then, it has revealed an extreme axial tilt, faint rings, and icy moons that rewrote the map of the night sky. The solar system is about 4.6 billion years old. Traced via meteorites, isotopes, and ancient rocks, our system began as a collapsing solar nebula forming the Sun, with remaining material accreting into planets, moons, and comets. Today's survivors are shaped by ancient collisions, migrations, and long cooling periods. Vesta has a layered structure like a planet. As the second largest object in the asteroid belt, Vesta is a differentiated protoplanet featuring a mantle and metallic core formed by ancient internal melting. A giant impact at its south pole exposed deeper layers, preserving Vesta as a pristine building block that never reached full planetary status. The Moon has quakes. Driven by Earth's tidal gravity, thermal expansion, or meteorite impacts, lunar quakes can last up to an hour. Discovered during Apollo missions, these quakes indicate that the Moon's interior is not entirely dormant, maintaining a quiet, pulsing heart despite lacking tectonic plates. Triton is a captured moon. Neptune's largest moon orbits in reverse, retrograde, suggesting it was captured from the Kuiper belt rather than forming in place. This violent capture likely destroyed Neptune's original moons and triggered tidal heating, leaving Triton with nitrogen geysers, a thin atmosphere, and strange cantaloupe-like surface textures. Neptune has 14 known moons. Ranging from large Triton to small, irregular, and dark bodies like Proteus and Naiad, Neptune's scattered satellite family offers clues about past planetary migrations and a violent history at the solar system's edge. The Parker Solar Probe is touching the Sun. Launched in 2018, NASA's probe flies directly into the Sun's outer corona at record speeds, enduring temperatures over 1,000 degrees Celsius behind a carbon composite heat shield. Its mission solves long-standing mysteries of solar wind acceleration and coronal heating by flying right through the stellar atmosphere. Some meteorites on Earth came from Mars. Blasted off the Martian surface by powerful impacts, these meteorite fragments traveled through space to fall on Earth. Containing trapped Martian air bubbles and water-formed minerals matching rover data, these wayward stones are direct geological samples from another world. The Sun is mostly hydrogen and helium. Comprising about 70% hydrogen and most of the rest helium, these light elements fuel core nuclear fusion, while heavier elements originated in earlier stellar generations. Despite its complexity, the Sun remains a glowing sphere of primordial gases shaped by gravity and nuclear fire. Earth's tilt gives us seasons. Tilted at roughly 23.5 degrees, Earth exposes alternating hemispheres to direct sunlight throughout its yearly orbit. When tilted toward the Sun, we experience summer with longer days. When away, winter brings weaker light. This tilt serves as the quiet architect of life's seasonal rhythms. Jupiter's magnetosphere is the largest structure in the solar system. Powered by currents in its metallic hydrogen interior, Jupiter's vast magnetic field spans millions of kilometers, creating fierce radiation belts, auroras, and capturing particles from Io's volcanoes. It presents a hazardous spacecraft and an extreme laboratory for magnetism. Planetary rings may be temporary. Formed from shattered moons or debris, rings around Saturn, Jupiter, Uranus, and Neptune are short-lived on cosmic timescales, eventually spiraling inward due to gravity and collisions. Saturn's rings, potentially under 100 million years old, may vanish entirely in another 100 million years, a fleeting, shimmering moment. The Moon's surface barely changes over time. without wind, rain, or active tectonics. The lunar landscape remains almost entirely unchanged for billions of years, preserving ancient impact craters and astronaut footprints against slow space weathering from micrometeorites. Some icy moons may have hydrothermal vents. Beneath the icy crusts of Europa and Enceladus, subsurface oceans may touch hot rocky cores, forming vents similar to Earth's ocean floor that support ecosystems without sunlight. If present, these vents provide heat, water, and energy sources, making hidden underwater worlds prime targets in the search for alien life. Sunlight takes over 8 minutes to reach Earth. Photons born in the sun's core take hundreds of thousands of years to bounce through dense plasma to the surface. But once free, they cross 150 million kilometers in just over 8 minutes. Looking at the sun means seeing it as it was 8 minutes ago, a glimpse into the recent past. Europa's cracked, ice may shift like tectonic plates. Europa's ice shell is crisscrossed with lines and ridges suggesting moving, breaking, and subducting terrain driven by Jupiter's tidal flexing. If confirmed, Europa would be the only known body besides Earth with active plate-like motion, cycling nutrients between surface and ocean. Saturn is less dense than water. Composed mostly of lightweight hydrogen and helium, Saturn's massive volume gives it an average density lower than water, meaning it would float in a giant cosmic bathtub. Rapid rotation flattens its poles and bulges its equator, puffing this gas giant into shape. Solar flares can disrupt technology on Earth. Sudden, powerful eruptions from the sun release intense radiation across the electromagnetic spectrum. When directed at Earth, they disrupt GPS, radio, and satellite operations, occasionally triggering geomagnetic storms that damage power grids, reminding us of the sun's volatile nature. The solar cycle influences auroras. Shimmering polar auroras intensify during solar maximum when sunspots and flares send charged particles hurtling toward Earth to interact with our magnetic field and atmosphere, painting the heavens with space weather. Comet tails always point away from the sun. As comets approach the sun, sublimating ice releases gas and dust. Pushed outward by solar wind and radiation pressure, the material forms two distinct tails, a curved dust tail and a straight ion tail, pointing directly away from the sun regardless of the comet's direction. Some planetary moons formed from giant impacts. Earth's moon formed from a colossal impact between early Earth and a Mars-sized body over 4 billion years ago. Similar impact origins are suspected for Pluto's Charon, contrasting with captured outer planet moons and reflecting the chaotic creativity of the solar system's birth. Voyager 1 carries a golden record into deep space. Launched in 1977, Voyager 1 travels further than any human-made object, carrying a golden record of sounds, greetings, music, and images chosen by Carl Sagan's team as a message in a bottle for any intelligent life that might someday find it. Earth shares its orbit with co-orbital asteroids. Small bodies follow stable looping paths near Earth's orbit via gravitational interactions, including Trojans hovering at Lagrangian points and horseshoe-shaped companions. These temporary, invisible fellow, travelers drift near us on our yearly journey around the sun. Neptune was once confused with Uranus. Because Neptune moves slowly and appears dim, early astronomers, including Galileo in 1612, mistakenly recorded it as a fixed star until mathematical orbital irregularities predicted and confirmed its true planetary existence. The edge of the solar system isn't defined by gravity. While solar gravity extends far out to distant comets, the energetic edge of the system is the heliopause, where solar wind meets the interstellar medium, marking the end of the sun's magnetic bubble. Planetary atmospheres slowly leak into space. Over time, light gases like hydrogen and helium escape planetary gravity via atmospheric escape. More pronounced on smaller bodies like Mars and Mercury or unshielded Venus, Earth also loses tons of hydrogen yearly, a quiet, constant exchange with the vacuum beyond. Some moons may have formed from ring systems. Ring systems can decay or clump together beyond Saturn's Roche limit to give birth to new moons like Pan and Daphne's, which act as quiet sculptors carving gaps and waves into the icy bands. Voyager 1 is still sending data from interstellar space. Over 45 years after launch, Voyager 1 transmits faint signals across billions of kilometers, measuring cosmic rays and plasma density using a nuclear power source, whispering data from the absolute edge of human exploration. The solar system completes a galactic orbit every 225 million years. Reconciling planetary motion with the sun's revolution around the Milky Way center, our cosmic year takes up to 250 million years, riding the galaxy's spiral arms like a slow cosmic carousel. And so, our quiet journey through the solar system comes to a gentle close. From the inner world scorched by sunlight to the icy moons that whisper in the dark, we've wandered together through orbits, storms, and shadows, one sleepy fact at a time. If your eyes are already heavy, that's just fine. Let the last traces of starlight fade behind your thoughts, and let your breath carry you softly into rest. There's still so much more to discover, but for now, you've learned enough. You've traveled far, and the universe can wait until morning. Thank you for spending this time with me. And so, under the quiet stars, the story continues. I hope you sleep well and dream softly. Good night.